Well, 7, graphing trig functions. So in this lesson, we're going to talk about how to graph all the basic trig functions. Like always, let's start off, since we're going to graph, let's talk about what sine looks like. Let's start off by making a table. Alright, so once we know the basic one, then we can apply all the basic rules to it and graph a graph any way we want. But let's see what a basic one looks like. So I'm going to put theta here and y here. Let's make a little chart, a little xy chart. So we have this. Now, normally I go 0, 1, 2, 3, but actually I'm going to do a little different in this one. Let's start with 0. So I can figure out what sine of 0 is. And actually the best way to find out what sine of 0 is do a little unit circle. 1, 0. Let's go pi over 2. Generally graph trig functions in radians. That's kind of the industry standard. That's why radians are so important. So at 0, remember sine e, sine is a y value, so sine is 0. So 0, sine is 0. Now I could do any one of them I want, but I'm going to go to the next big one right here, pi over 2. And the sine of pi over 2, sine is a y value, 0, 1. So at pi over 2, say that's pi over 2, it should be at 1. And then the next big one is right here, pi. So at pi, that is negative 1, 0. Sine is a y value, sine 0 again. And then we go to 3 pi over 2, that's the next big one, right here. 0, negative 1. Sine's a y value, so negative 1. So 3 pi over 2, negative 1. And then if we go 2 pi, so go all the way back around to where we started. Well, sine of 2 pi is 0, it's like the first one. We go back to 0. And if you keep on going, it's going to be the same thing, right? Because after that, we go up here, over back to 1, then back down to 0. This is a periodic function, just like the last lesson we talked about. So sine and cosine graph are periodic functions, and they go on forever. So that's what a sine graph looks like a straight up basic sine graph. I could do the exact same thing for cosine. Let me show you a basic cosine graph, and then we'll talk about these graphs in general. I'm not going to do the table, but I'll do the same idea. So let's say this is 1, negative 1. Let's go. Let's use the same values. Pi over 2, pi over 2, pi, 3 pi over 2, and all the way to 2 pi. So x is my y. Right. So if we did cosine right here, cosine of 0. What am I starting? Look over here. Cosine is 0. Cosine is the x value, so cosine starts at 1. And if we did cosine of pi over 2, which is the one right here, cosine is the x value, so cosine is 0. Then let's move on to pi. Cosine is the x value, so cosine is negative 1. And then we move on to 3 pi over 2. Cosine is the x value, so now it's back to 0. And then we move on to back to where we started, which is 1 again. This is what a basic cosine graph looks like. And just like as always, it'll just repeat itself over and over again. You get that. So that's a basic sine graph, a basic cosine graph. If you notice, these are actually the same graph just moved over. Like if you look at, let's say we started right here. That graph right there is the same graph as a basic sine graph. It's just moved over a bit. So they're actually kind of the same graph. Sine starts at the origin, starts at 0, and cosine starts at 1. Let's break this down a little bit more. So if we look at this, see how long it takes to repeat itself? We talked about this last lesson. That's called a period. Now here's a new thing. How long it takes to get from the middle, so this is like the middle right here. See how it kind of oscillates around that, to the highest point or the lowest point, call that the amplitude. Right, so the amplitude of this thing is 1. And the period, how long it takes to repeat itself, is 2 pi. So that's the amplitude, that's the period. That amplitude tells you how high and how low you go. Period tells you how long it takes to repeat itself. So that's a general idea. Now how do you notice it? How do you figure out what amplitude and period are? Well, let me erase this because I need some room. Sorry if you can't do this on your paper. Well, a basic sine cosine graph looks like this. So y equals a cosine bx. That's the same way for sine. And if you want to know what the amplitude is, it's just the number in front. So that's the amp. So in this case, the number in front was 1, so we just only went to 1 down to 1. Same thing with cosine. The number in front was 1, so we went up to 1 and down to 1. The way you find the period is a little more interesting. It's another formula. It's 2 pi over b, where b is this number right there. So like in this case right here, it would be 2 pi over, there's no number right there, so 1, so just 2 pi. If you notice, our period was 2 pi. So that's the basic formula of how to find stuff for sine and cosine. You need to know how high it goes, how low it goes, called the amplitude, how long it takes to repeat itself, which is a period. And once you get those two things, you just kind of graph it. Sine graph starts at the beginning, ends at the same spot, halfway in between. Half between these two is my highest, half between these two is my lowest. It's connected. Cosine's different, it starts on top, ends at the same spot, halfway between the lowest, in between is where you cross. That's the general idea. So now let's do some examples. So all they want me to do here is to find the amp in the period. So my amp here is the number in front, 3, done. The period's a little more work. It's 2 pi over b. That's your b. So it's 2 pi over 5. And that's pretty much it. That's the period, that's the amp. Over here, amp is the number in front. There's no number in front in this case, so it's just 1. The period, 2 pi over b, I meant to do this last time. I didn't write the formula. There it goes. B's the number right here. So you get 2 pi over 1/2. Now you can't leave it like that. We're not scared of this anymore. Just the same thing as a divide sign. So it's 2 pi times reciprocal. So it's 4 pi. And then one over here. The amp, again, just the number in front. So 3. Period is 2 pi over b. In this case, there's no b, so it's 1. So my period is 2 pi. Amplitude is kind of like a vertical stretch, right? It works the same way. So if it's a bigger number, you go higher. If it's a smaller number, you go lower. Just like a vertical stretch is. That's why it's the number in front. So that's how you find the amp and period. Now when we graph these things, that's the first thing we want to find. So let's do some graphing. Now, again, if I want to graph this, the first thing I want to find is the amp and the period. That says amp. My amp is 2, number in front. Period is 2 pi over b. There's no b, so it's just 2 pi over 1. Or 2 pi. So we're going to graph this now. It's actually a lot easier if I give you a grid. So a lot of times I'm going to give you a grid. But let's just go pi over 2, pi, 3 pi over 2, and 2 pi. Again, this is a normal XY grid. It looks a little funky because we're going to that far. But it's the same grid as always. You can go -1, -2 if you want. Pi is like 3.14, so that'd be like 3 right here. But most of the time we just use this. So like that. Now doing sine. Remember, sine, a basic sine graph should start at the middle. My period's 2 pi, so that's where I should end. Start at the middle, end at 2 pi, and that's your period. It takes you that long to finish. Sine has a halfway mark right here. And then halfway between these two is my highest point, which in this case is my amplitude of 2. And then halfway between these two is my lowest point, which in this case would be -2. And that's the idea. Just connect them. Again, these go on forever. I can't really draw because it's me and I can't draw. That's the idea. Let's look at another couple of them. This one right here, right? Same idea. Let's find the amp. 1/2. Let's find the period. 2 pi over b. In this case, I do have a b. It's 2. So 2 pi over 2. So pi. So I'm going to try to draw the same graph. I'm going to try to draw it the exact same way, besides the fact that I can't draw. So it's pi over 2, pi, 3 pi over 2, 2 pi. Let's make this 1, then 2. -1, -2. Now this is another sine graph, so we should hopefully know how the way it starts now. You start at the origin. Sine starts at 0. I'm going to end at pi this time. It's my period. So right there. Halfway in between will be pi over 2. Half between these two is my highest, which in this case is only 1/2, so I have to go like right here. Half between these two is my lowest, so it's another negative 1/2. So my graph looks like this. Something like that. Again, I can draw. But that's the idea. Notice how it's shorter because the period's shorter, and it doesn't go as high because the amp is smaller. Now, in this case, this is only one rotation. Remember, this goes on forever. If I really want to, I could do it again. So another period would be pi plus pi would be 2 pi. Halfway would be right here. In between these two would be my highest, which would be 1/2. In between these is my lowest, negative 1/2. And I could draw another period. And I can keep on going. Right? Because it's a periodic function. It just keeps on repeating itself. Both ways. I go backwards also. So let's keep that in mind, right? It doesn't just stop there. It goes on forever. Sine and cosine graphs do that. Now let's move on to cosine graph. Same idea. Amp is 1 because there's no number in front. Period is 2 pi over b. Now my b in this case is 1/2. So 2 pi over 1/2. Which we did earlier. It's the same thing as saying 2 pi divided by 1/2. Which is the same thing as saying 2 pi times reciprocal. So that is 4 pi. So I'm just doing a little different because I don't want to write forever. Hey, that was a pretty straight line. I didn't expect much. So this is pi. Whew, let's just do that. Let's go by pi's now. So that's pi. So hopefully around here is 2 pi. I'm trying to eyeball it. It's like right here is 3 pi. I gotta keep on going so I get to 4 pi. So let's keep on going. I'm trying to eyeball this. So let's say that's 4 pi. Remember, pi is like 3.14. So this is like almost 12 out. If I was looking at a normal number chart, it'd be around 12. Amp is 1, so I can see this normal. It's like 1 and 2, 1 and 2. Okay, let's graph a cosine graph. Remember, cosine's a little different. Cosine starts on the top. So cosine will start up here. And you always end the same spot. Halfway in between is my lowest. In between is my red crosses. So if I was doing this one, I'm going to start at 1, because that's my amp. At the end of my period, that's how long it takes me to finish. It's going to be 4 pi, so that's where I'm going to end. Halfway in between, which would be about 2 pi, would be my lowest, which in this case is negative 1. Then halfway between these two, which should be about pi, is right across. Halfway between these two is right across. And that is my cosine graph. Should look kind of like a U. My graph sucks. But it should look something like that. Oh, that's awful. Don't forget, it goes on forever if I really want to. I can keep on going and go all the way to 8 pi. Or I could go back to negative 4 pi. But that's the general idea. Let's do one more basic graph and then we'll move on to how to graph tan. So, in this case, again, amp. So number front, so 3. Period is 2 pi over b, which in this case is 1. So just 2 pi. Now, I don't have to go as far as I did last time, because there's only 2 pi, but here's 0, here's pi, here is 3 pi over 2, there's 2 pi. I can keep on going if I want, but eh. My amp is 3, so make sure we go up to 3. 1, 2, 3, 1, 2, 3. Again, we're doing a cosine graph. Cosine starts on top. Since I start there, I gotta end the same spot where my period is. So I'm ending right there. Halfway in between is my lowest, which in this case, halfway between those two is pi. Halfway up 2 pi is 1 pi. And then in between these two is right across. In between these two is right across. And that is my graph. Right. Again, if I was gonna go on again, I'll just do another period. Since this is 2 pi, it'll be another 2 pi, which will be about 4 pi. And I keep on going. That's a basic cosine graph, right? So cosine graph starts on top, ends on top, halfway is the lowest. A sine graph starts in the middle, ends in the middle, halfway is where you cross. So those are basically those. Now let's go on to tan. So we're gonna skip that because eh. So this is what a tan graph looks like. It's a little different. If you remember tan, when we do tan, it's undefined at the y-axis at 90 and negative 90, or pi over 2, negative pi over 2. So it has these things there. Now here's the thing. I'm never going to ask you to graph tan. You might have to do an honors math analysis, but in my class in IB, we don't actually graph tan. So I want you to know how to graph with the calculator though. So let me show you how to do that. So here's my calculator. You'll see right now. There it goes. So there's the calculator. So let's turn it on. Now here's the thing about graphing trig functions. We always graph them in radian mode. So make sure you're in radian mode. I was not. That would have been embarrassing. So then we go to y equals. Let's delete so I don't need anymore. So tan of 2 pi. So let's go tan 2. Now we don't have a data. Well, actually we do have a data button, but it's not on right now, so we're just going to use the x value. So like that. If we hit graph, you can see this. Now my window's a little off, but if you look at it, it does look like a tan graph right there. So that's what a tan graph does. It starts down there, goes up, and just constantly repeats itself. I can do something for 1/2 tan, but Let's talk about, so that's how you do a basic tan graph, a basic sine, basic cosine. So we're going to finish off talking about the other inverse trig functions, specifically cosecant, secant, and cotan. So here's the graphs of cosecant, secant, and cotan. Now they're actually not as bad as they look. Cosecant is opposite of sine. If you look right here at the dotted line, ignore the parabolas for now. Look at the dotted line. That's a sine graph. So the graph of cosecant graph, all you do is draw a sine graph. Then at the x-intercept, you add asymptotes. And then at the maximum, you add parabolas. You want a secant graph, right? Secant is opposite of cosine. You're going to see a cosine graph. And just like we do over here, we're going to add asymptotes at the x-intercepts. And we'll add parabolas at the min and max graphs. Now cotan is just it's kind of like the inverse. It moves the opposite way of a tan graph. There's a little bit more to that, but that's the general idea. And again, cotan graph I'll only ask on the calculator. So let's graph a cosecant graph. So first thing I'm going to talk about, cosecant is the opposite of sine, reciprocal sine. So sine 2 theta is what we're really going to look at. So let's find the amp and period like we always do. Amp's number in front, which is 1. Period is 2 pi over b. In this case, my b is 2. Number in front of the theta. So I get 2 pi. Now let's draw a line. We'll go pi over 2, pi, 3 pi over 2, yada yada. Amp is 1, 2, 1, 2. Like that. Now the first thing we're going to do, since we're going to graph cosecant, let's graph sine, but we'll make it dotted. Right, so sine starts at the origin, ends at the period, which is 2 pi here, so we're going to end right here. Halfway between would be pi over 2. Highest I go is 1. Lowest I go is -1. So let's connect these dots, so we'll do a little dot line. And again, if we want, we can keep on going. I can even go backwards if I want. Now to make this cosecant graph, we have to add 2 things. We have to like pimp it out. First thing we're going to do, at the x-intercepts, we're going to add vertical asymptotes. And then, the final touch, at the min-max points, we're going to add parabolas. Now don't get sloppy with this. You don't want to go past the vertical asymptotes. You cannot pass them. Something like that. Right, so can't go past the vertical asymptotes. But there is my cosecant graph. It's just a sine graph with a makeover. And that's the general idea. Let's do one more, or a couple more. Ooh, first thing, we already did a cosecant graph. Let's make that a secant graph for prosperity. So that's secant. 3 tan, again, I'm only asking you to do this in the calculator. Actually, one thing I do want to talk about though. Period we know is period 2 pi over b. That only works for sine and cosine, and secant and cosecant. Tan, the period is actually pi over b. If we look at the graph of tan, the period that only goes, well, it doesn't show you here, but it's pi. It only goes pi across. It doesn't do the whole thing. So, period for tan and cotan is pi over b. So my period here is going to be pi over 1, because no b, so just pi. Like if I want to graph that, I'll just have you do it in the calculator. You can see it looks like something to this effect. Same thing for cotan. If I'm on my period, it's just like the period right there. So pi over b. In this case, it'll be pi over 2. And you get that. If I was going to graph it, now cotan is a little different, but I'll have you do it in your calculator. It would be something to this effect. Those are very crude drawings of what I wanted to do. Anyway, let's finish this off with 2 secant. So again, secant, the way you graph that, you just want to graph its reciprocal function, which in this case is 2 cosine. So I'll find the amp, which is 2, the number in front. Find the period, 2 pi over b. There's no b, so just 2 pi. And then if I'm going to draw it, Right, so I gotta go all the way to 2 pi. So here it says this is pi, this is 2 pi, halfway, halfway. Like my amp is 2, so make sure we go up to 2 at the very least. And if we're gonna graph this, we want to graph, trying to graph 2 secant. Let's graph 2 cosine. Let's do it dotted. Now cosine starts on top, so it starts at the amplitude. Starts right there, ends at the same spot. Halfway is the lowest. In between these two is where you cross. And that's my cosine graph. Now I want to make it a secant graph, so we got to add some things to it. First, we're going to add some asymptotes at the x-intercepts. And then we'll add parabolas at the min-max points. So we'll add a parabola here. We'll add a parabola here. There you go. That's how you graph secant and cosecant and sine and cosine.